Hello. In this video, we will learn why a heat engine needs to reject heat. Heat engine is a device which takes heat from a source and rejects heat to the sink and produces work. Here, the turbine is a heat engine which takes heat from the boiler, rejects heat to the condenser and generates work. But why this heat rejection? That is what we are going to discuss. To understand why the heat engine rejects heat, consider a system confined within a piston cylinder arrangement and initially at a temperature of T. If this system pushes this or moves the piston, then we say work is done by the system. In order to move the piston, we bring a reservoir at temperature T1 in contact with the system. A reservoir is a body that can supply or absorb without change in its temperature. In our discussion, the temperature of the reservoir T1 is greater than T. That is the initial temperature of the system. Since there is a temperature difference between the reservoir and the system, heat flows from the reservoir to the system and hence energy of the system increases. This increase in energy moves the piston to the right. Definitely, the piston will not move continuously. It will stop at a particular point. So what is the point at which it stops? Look at the sketch. T1 is the final temperature of the system. That means the system has undergone a change of state. From the initial temperature T, it reaches the final temperature T1. The piston stops when T is equal to T1. There is no heat transfer at T equal to T1. That means equilibrium is reached. In other words, the engine stops when equilibrium is reached. Stopping of engine means it no longer can deliver work. During the state change from initial temperature T to the final temperature T1, energy in the form of heat is added and the magnitude is Q1. Suppose if you want to make the engine to deliver work continuously or again, we may think of replacing the reservoir with a new reservoir whose temperature is greater than T1. So we can keep on increasing the temperature of the reservoir and try to generate more work or try to generate work continuously. Whatever be the reservoir temperature, definitely there will be an equilibrium condition. But the material of the piston cylinder cannot withstand temperature beyond a limit. Therefore, the concept of increasing the reservoir temperature is ruled out to deliver work continuously. What is the alternate way? Disturb this equilibrium. How we are going to disturb this equilibrium? Remove this reservoir. Bring another reservoir in contact with the system whose temperature is T2 and T2 is less than T1. Once again, there is a temperature difference between the system and the reservoir. Now the system is at a higher temperature. Therefore, heat will flow from the system to the reservoir. So heat will flow from the system to the reservoir and restore the piston back to its initial position. Now heat is rejected. The quantity of heat rejected is Q2. Once again, there is a change of state. The system at T1 reaches a temperature T. T is less than T1. Or we can say the system has completed a cycle. It was initially at temperature T, was taken to temperature T1 using the reservoir at T1, and it is brought back to its initial state T using another reservoir at temperature T2. So the system has completed a cycle. What first law of thermodynamics says? If a system undergoes a cycle, net heat transfer is equal to net work done. What is that? W equal to Q1 minus Q2. What is that Q1? Q1 is the heat added to the system, therefore it is positive. Q2 is the heat rejected by the system, therefore it is negative. So the difference in quantities is equal to work. Hence the system obeys first law. Therefore, for a system to deliver work continuously, it should not be in equilibrium. Here the gas confined within the piston cylinder arrangement is the system. How that equilibrium is disturbed? By the rejection of heat. Before proceeding further, we define two terms. One is source. In our example, source is the reservoir that supplied heat. Sink is the reservoir at temperature T2 that absorbs the heat from the system. So source supplies heat, sink absorbs heat. What is next? Just now we discussed work W is equal to Q1 minus Q2 in a cyclic heat engine. What we infer from this is not all the heat added Q1 is converted into work. Obviously, Q1 is greater than W. This inference leads to the discussion difference between heat and work. Heat and work are not completely interchangeable. We take work as high grade energy and heat as low grade energy. Conversion of or complete conversion of low grade energy into high grade energy is impossible. So what we discussed is for a cyclic heat engine to work continuously or to deliver work continuously, it must reject heat. Heat is added by bringing in contact with the source, and heat is rejected by bringing in contact with the sink. So this is done in a cyclic manner repeatedly for the cyclic heat engine to work continuously. Thank you.